Whew, okay. All right, so observe, we're gonna be approximating pi today. So here's a circle with radius 1, and in it is inscribed a triangle. Now if we segment this triangle into 3 parts, each part has a degree measure of 120 degrees. And if we drop an altitude, we get a 30, 60, 90 triangle. Now observe, this little guy is too small. We're gonna look at him right here, okay? So we know that it has a radius of 1, illustrated by this length. Because it's a 30, 60, 90 degree triangle, we know that this is 1/2. Conversely, this is root 3 over 2. So first we gotta find the area of this triangle. We have to multiply it by 6 because there are 6 of these little tiny half triangles in this entire one. And then we're going to divide it by 2 because the formula of the area of a triangle is 1/2 base times height. So first, we're going to take this value, the cosine value, we're going to say cosine of 30 degrees, this degree measure right here, we're going to multiply it by sine 30. Now, look over here. It's the same thing, multiply it by 6. 6 times cosine 30 times sine 30. And then we divide it by 2, and we end up getting 1.299 units squared. Never forget the units. Now, from this, we can derive a formula for finding polygons inscribed in circles with radius 1. Now, observe this formula. It's n times cosine 180 over n times sine 180 over n. Now, thinking about polygons inscribed inside of circles with radius 1, as the number of sides increase, the closer it gets to pi. Because if you think about a circle with a radius of 1, now excuse my drawing skills, let's pretend this is a radius of 1, right here, 1. The formula to the area of a circle is, well, excuse this marker, I'm going to need a new one, is pi r squared. And we know that the radius is 1. So pi 1 squared, that equals pi. You heard it from me, okay? So it equals pi, and now let's pretend that we have, let's say, 999 sided figure, and it's inside this circle. The closer it approaches to the actual dimensions of a circle, is the closer you get to pi. Now, if that's unclear, it's the same with a polygon that is circumscribed around a circle with radius 1. Now, excuse my drawing skills again, but let's pretend that's actually accurate. Now, this has a radius 1. As the number of sides increase, the more it forms to the size of the radius 1 circle, and you get closer to pi, which is the area of a circle with a radius 1. Thank you.